going to look at another infrastructure service, Azure networking. Of course, as we move workloads, virtual machines, applications, and such to the cloud, they still have to be able to communicate over the network. They have to be able to communicate with one another in many cases. They may have to be able to communicate with on-premises environments. And they certainly have to be able to communicate and respond to internet clients that are going to be accessing them. So networking, as you might imagine, is a fairly, big section and pretty important when it comes to running workloads in the cloud. So we'll talk about some virtual networking fundamentals, the different components that are involved, and you'll see that those are things like a virtual network, a subnet, a private and a public IP address, those kinds of things. Network security groups that provide firewall capabilities, etc. We'll talk about connecting virtual networks and the different options that you've got. Look at securing virtual networks, both at the interface level as well as more of an appliance like the actual Azure firewalls or application gateways. And then we'll talk about and discuss how do we go about connecting to on-premise environments. Within Azure is one thing, but how do we connect a VPN to a customer location? How do we use something known as express route? What are the options for client VPNs? Those kinds of things. And we'll discuss as well how to control network traffic. The fundamentals of virtual networking in Azure. All right, so let's talk about just an introduction here. Virtual machines and their operating systems, as we mentioned, require network connectivity just like any other physical machine. They require network connectivity in order to be able to communicate with one another. They have to be able to communicate with internet hosts, and then potentially to be able to communicate with remote networks, remote subnets. So when you move to the cloud, it limits or eliminates the physical network requirements for your organization. And in doing so, just like with other things, it makes some scenarios much more plausible. In other words, organizations don't need to maintain expensive data centers. They don't need to have high availability through UPS systems, generators. We don't need multiple ISP connections to the internet, things like that. And in some larger organizations, that simply eliminates that complexity and requirement from the network. But in smaller organizations, that's why I say makes scenarios much more plausible. I'm actually thinking small to medium-sized businesses there. Small to medium-sized businesses may not have the budget to implement this type of high availability and things like that. So it actually opens up a lot of possibilities for them. Whether it be high availability and routing, load balancing, load balancing security solutions, load balancing also from a performance efficiency standpoint on web servers. Certainly much easier configuration because we're talking about virtualized components. I mean, I can create a virtual network and 4 subnets and place VMs in a matter of about 20 minutes in the cloud, right? I can set up an application gateway and a firewall in a very short period of time. Set up load balancers for my web servers because we don't have anything to do with the physical components. We're simply setting up the virtual kind of logical representation of that. All right, so the primary component is, of course, going to be the virtual network, often just called a VNet. This is a representation of your own network in the cloud environment. It's also a logical isolation of the Azure cloud, and it is dedicated to your subscription. We can use VNets for a couple of things. We can use them to just connect systems within the cloud. We can use them to manage VPNs to an on-prem type of environment so that we have a hybrid or cross-premises solution, those kinds of things. Now, each VNet has its own CIDR address block. CIDR is classless interdomain routing. Hopefully everybody's somewhat familiar with that. That just simply means, subnet masks are created on an as-needed basis at the length that they are needed. And so we write the IP addresses in the form of IP, then slash, and then the number of subnet bits. Okay, so a CIDR address block of, say, 10.0.0.0/16. Okay, so when you create a VNet, it gets its own address block. Then each individual virtual machine is going to have at least one virtual NIC, network interface card, connected to the VNet. that NIC would then get a private IP address, and then potentially those virtual NICs can get public IP addresses assigned to them as well. VNets can be linked to other networks on premise or in the cloud to provide connectivity, and then we can also create additional subnets. So within the virtual networks, if you just want to increase options there, you can create additional subnets. So you'll have the initial block, and then we can create some subnets within that block. And again, this is all very easy to do. You do have to understand subnetting and how that works, but we'll kind of go through that as we go along. So there are several uses. One would be a dedicated private cloud-only VNet. And I think I've probably mentioned all of these. That would just be, okay, you don't require any communication with an on-premise network. Typically, when organizations start out using Azure, they don't have a private cloud-only VNet because they do have some sort of hybrid cloud scenario, or they're extending their on-premise environment with a site-to-site VPN, and that may be just to get stuff moved. Okay, so for instance, I do lots of projects where we are eliminating on-premises servers and we're moving them to the cloud, but we still, set up the virtual networking first to host whatever servers, typically then migrating data, migrating the servers into Azure before we break that connection. So you can have a cloud-only VNet, or we can extend on-premises environments just to take advantage of Azure capabilities or to migrate, and then also to enable the hybrid scenarios. Now, virtual networks require the same connectivity components as their on-premise counterparts, so there is no difference. Everybody here should have a good amount of networking background, I would think, so we're not going to spend a ton of time here. But, basically, I am going to need an IP address, right? Just because I'm a virtual machine, a virtual NIC, doesn't mean that the basic connectivity requirements are different. So I have to have an IP address. You will get a private IP address that will be assigned automatically to all of the virtual machines within a particular VNet. Okay, you can purchase public IP addresses. The default for the public IP address is dynamic, and if you want to, you can purchase a static if that makes more sense. Say for a web server, database, something that's accessible from the outside permanently. Often we do a static IP. Because otherwise, if that resource gets deprovisioned, you will lose the public IP address. We've also got subnets and subnet masks that are going to be required. As I said, you can create additional subnets if necessary, and routing is enabled between the subnets within a virtual network by default. We will have to understand how subnet masks go because the subnet ranges can't overlap, but Microsoft always uses the private, quote-unquote, Class A range of 10.0.0.0 with a 16-bit mask. And a 16-bit mask means that you still have 16 bits to play with. That's to 65,534 IP addresses that you potentially could have. And so, it's pretty easy to create non-overlapping subnets. We can just go 10.0.1.0, 10.0.2.0, 3.0, and a 24-bit mask. So you have to think about it, and actually the Azure portal won't let you create it will not let you create an overlapping range. Okay, so that's not even going to be an option for us. All right, the other thing is you will need a default gateway that's going to be configured automatically. Again, inter-subnet routing within the VNet is by default, and all virtual machines running in Azure will be able to communicate with the internet by default as well. Okay, and we are going to need a DNS server. We can just use the standard DNS. If you've got an actual domain running in Azure or something, then we would need to modify that DNS server. I do want to mention one thing here. You cannot, and I'll probably say it again, you cannot change virtual machines IP configuration the way you do a normal server. All right, this is not probably a testable thing, but this is very, very real world. Trust me. you can, right? You can go in, you can RDP into a VM that you just created, and you can go in and modify the IP configuration, and you will never connect to that system again once you do that. I have rebuilt several VMs because I forgot that early on. So you must go in and modify the virtual network settings through the portal or through Azure PowerShell. You cannot do it directly within the VM itself. So, but as we see, and as I mentioned, I mean, these are the same components. I need a unique IP address within a particular subnet. I need a default gateway to get off, and I need a DNS server to do name resolution. In this demonstration, we're going to look at working with virtual networks. We are starting here our chapter on virtual networking and discussing just the various components. And so we'll go ahead and log into the Azure portal and get started in that area. All right, so nicely it logged me right back in. Of course, we can go to, whatever resources we want. This is my Windows 10 machine that I'm actually utilizing for demo purposes. On any virtual machine, you can click on the networking under settings, and you will see the network interface, the name of it, as well as the virtual network and subnet that is being used for that network. Okay, and so you can just select that if you want. That would be one way of getting into a particular VNet. So in this case, this is a virtual network that has already been created. We get a general overview, but down under settings, we can see address space. So we see the general address space here is 172.16.00/24. So my address range is from 0 to 255 in the last octet, just like a class C, even though that's technically a class B if you want to go back to the classful system. And then we can click on subnets as well and see how many subnets we've got. Right now we've just got the default subnet. But with a 24-bit mask, we could certainly create additional subnets if we like within that class C range. Okay, or within that last octet we could create subnets, or we could even create subnets in the third octet. But let's back up. Let's go as if we were going to create a brand new virtual network. All right, so just type in virtual. Virtual networks would probably be one of the first that pops up. We've got a lot here, of course, in our demo environment here. I am going to use the same resource group, but I am going to create a different network because that'll help us to show how we can make sure we're routing between networks and things like that later. So I'm going to click New, create a new virtual network. We'll get prompted for the subscription. We will then get prompted for the resource group or have the ability to create a new one if we would like. Okay, let's see. The first was PL test. We'll just call this VNet 2. Okay, also in the East US region. And then we can just hit review and create, or we can go next and configure IP addresses. So you can see the IP address space that it has assigned. It's gone ahead and done 172.18.00 with a 16-bit mask. That is the default address space. You're always going to see a 16-bit mask on the default address space. Now that we can change this to whatever we want. But quite honestly, it doesn't really matter as long as it's not overlapping with something else. So in the virtual network, the original virtual network's address space was what? 172.16.00.24. You're probably better off at leaving it at 16. At a 16-bit mask. Okay, so I'm actually just going to leave that. That is my address space for this network. Within there, it is going to create a default subnet, and that default subnet is going to be just the main network ID, 172.18, then .0.0, but we're doing /24. You can add additional subnets if you would like. So let's say we want to add a DMZ subnet. So we're going to do 172.18.1.0/24. Okay. So notice that is a different range, but it's still within this main address space, right? This main address space gave me the flexibility to control those last two octets. So then I extend the subnet mask to 24, giving me access to the third octet with my first network being 0 and my second network being 1. Or we can change that. If you don't want to have a 0 network, that's fine. We'll do that. Are we utilizing a network address translation gateway? You can do that in order to simplify connectivity to the internet. We haven't really talked about some of these things as of yet, so I'm just going to add the subnet for DMZ. You can always go in and modify the default subnet, and I'm going to do that just so maybe it makes it a little easier for us to identify, okay, we've got the 1 network and we've got the 2 network, basically. Okay. Next, security. You can choose, some of the security features. Do you want to enable, disable the firewall on this? This is a DMZ, so I am going to go ahead and enable the firewall, and then we'll be talking about this a little bit later. PL test firewall. I know these names aren't great, but this is a demo. Let's disable this for now, and we'll come back to that a little bit later. Next is metadata tags. We're not going to do those, so we'll hit review and create. And then create. And virtual networks and subnets are not going to take very long to create because it is very much logical. So we've already actually gotten the notification that it was successful, although my page here still says in progress. There we go. And now we can go to the resource. So now when I go to my test VNet 2, 172.18.0.0 with a 16-bit mask, my subnets are 172.18.1.0 and .2.0 called default and DMZ. And right now I would have no connected devices. Okay, but we can go and we can create additional virtual machines, and I'll probably do that for just demo purposes. So we'll create another virtual machine that actually exists in this subnet, and then show what we need to do in order to first connect virtual networks in Azure, and then secondly, to secure the type of traffic between them. But that's going to complete this demo. In this demo, we just wanted to look at the creation of virtual networks and the configuration of address spaces and subnets.